Hello and welcome to today's daily challenge. Let's begin our question. Okay, so question 443, string compression. Given an array of characters char, compress it using the following algorithm. Begin with an empty string s. For each group of consecutive repeating characters in chars, if the group's length is 1, append the character to s. Otherwise, append the character followed by the group's length. Okay. The compressed string s should not be returned separately, but instead be stored in the input character array chars. Note that group lengths that are 10 or longer will be split into multiple characters in chars. After you're done modifying the input array, return the new length of the array. You must write the algorithm that uses only constants as extra space. Okay, so the compression here is sort of intuitive. It makes sense. A string with consecutive repeating, a group of characters that are consecutively repeating could be replaced with a character and then a number representing the number of occurrences. Therefore, let's look at some examples. Input chars. Oh, so it's fed to us as a array of characters. Okay, so an array of characters that goes A, B, B, C, C, C should be A2, B2, C3. A2, B2, C3. Great, awesome. Example 2, A. Oh, so there was a condition that if the group's length is 1, simply append the character without the without the number afterwards. So this is just going to be A, and here in example number 3 we have a single A followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 B's. Okay, so we have a single A that doesn't proceed with a number, and then B12. But the 12 is split up into 2 characters. Okay, so this is the condition here where if the group's length is 10 or longer, will be split into characters in char. Okay, let's see. The simplest, I think, solution would just be to have a loop iterating over chars and a holder, like a variable representing the current character that we're on and the number of times that the character has been repeated. And as we're iterating through chars, there's a condition that if the next character that we're looking at is going to be different from the one that we're currently on, then do logic to create an entry representing that character. So if the if the running count for that character is, let's say, 1, then we simply append the current character. Otherwise, we append the current character and the number of occurrences. The problem with that is that we have to use constant space. Constant extra space basically means that we cannot have what it actually means is that we cannot create any sort of dynamic structure in here. We can only use variables. Things like arrays that are constantly growing, which would be the case if we were to implement what I just said, are not allowed. We should be utilizing this chars array as our as our output as well. So what I'm thinking is, let's start treating this chars as the output for our logic. I think it should work because as we're iterating through the input chars, the place where we're going to be writing our compressed information should always be written in place of things that we've already that we've already passed. So for example, if an input array is something like a b b b b b, and this is like the working index, right? As we're iterating through first this one, then this one, then this one, then this one, then this one, when it finally hits the condition that the current and the next don't match, the place where we're going to be writing our result is actually in the compress index. So it's always going to be writing to a place that we've already worked through. So it shouldn't be the case that we're overriding something that we actually care about. I'm gonna leave this here just as a visual guide. Okay, since that the previous solution that I mentioned, where the output array is separate from chars, should be the right track. So we can have a running count equaling 0. We could have a current. Okay, let's actually quickly think about this loop. We're going to be operating on each one of these characters, and we are in need of two. We need an iterator, we need a condition when to write report. The report I'm referring to as this pair, A and 2. And then also modifying the report. So in the case where it's the same, we're going to append 1. In the case where it's different, we're going to write the report. So actually these two, they are sort of, so modify / initialize report, and condition, this is just the condition of current versus next. Okay, so we have these three things. It's pretty clear that we can say for I in range chars, this is our iterator. We're going to be looking at the current character and the next character. How would we do that? Let's say current. Okay, so let's have this actually be I guess the next. Yeah, let's have next indx being I plus 1. Current is just going to be this. And then let's say, well, what is our first condition? If, okay, cur char if current char does not equal next char. So what is current char? Current char is just going to be chars I. Next char is just going to be chars next index. Let's see. So I'm just writing up the condition for when we're going to be what we're going to be doing, either iterating, so either modifying the report to fit the new character, or okay, so if current char does not equal next char, then we have to write, no. Let's start with the simpler. If it does equal, then running count plus equals 1, else, let's actually have a print statement. So cur char and maybe running count and a reset of the running count. So this is the modifying slash initializing. This is the modifying and this is the initializing. So if we get this print statement to print A2, B2, C3, then pretty much all that's left is replace this print statement with a mechanism to actually write the result, write the print statement into the chars. All right, so this should be pretty, if we get this right, then the rest should be easy. Let's see if we are wrong here, because next char is actually I plus 1. So we can say that, let's say if I is equal to len of chars. So this is an edge case where next char is going to be a fake character, because when the current index is looking at, when the current index is looking at the last element in the array, next char is going to be pointing to something that doesn't make sense. In our case, I'm going to hard code it to be an underscore. And sweet. Also mistake. While while next indx, there we go. Sweet, so we get A1, B2, C3. Is this because the initial, it might be because the initial, initially we have to preset running count to being equal to 1. So now that we have this down, all that's pretty much left is to replace this print statement with the correct mechanism to write down the result here. And I'm thinking that would be something along the lines of, let's just comment this out for now. Let's have a writing index, or writing index. It's going to be starting at 0. Writing index is compressed index, we decided to call it that. Compress index, to be starting at that. And let's say that here we're going to, so the current char is what we care about. So what do we actually have to do? We have to say that char's writing compress index is equal to cur char. I'm going to append 1 to this, and then I have to write the number itself. So how do I write the number? Char's compress index is equal to running count compress index shoot plus equals 1. Okay. Oh, and we also have to return the length of the new array. Okay, there we go. Oh, and these have to be strings. And the index assignment is out of range. That is probably because we need this weird condition that if len chars is equal to 1, return 1. List assignment index out of range. List assignment index out of range. What? How could this be? Compressed index, I'm just appending 1 out of range str. Interesting. Whoa, it's so weird. Okay, so this is a test. This is one of the test cases. Let's actually just run this and see what's going on. If print statement could be useful. Cur char running char, and let's have the compress index. Huh. Whoa, this is confusing to me. Why is current char being printed as 1? Current char is being printed as 1 because it is being overwritten by one of these. What if we just, what if current, where's current char? What if current char is just a, sorry. Yeah, this could be a thing that when we, you know what it is? No, this was correct. There was a condition that in the case that the number only appears once, then so basically we don't care about writing the number of repeated times if, there we go. Sweet. Okay. Reset test cases. What happened there was we were writing, we found that A exists only once, and then overwrote that this element in the array, which we hadn't yet processed, is actually 1. because A was repeated once. So I have the condition here that falls in line with the requirement that if a group's length is 1, simply append the character without the number of occurrences. So now that I have this, am I done? Am I done? What is the problem here? Oh, the problem here is that I'm not splitting 12 up into 1 and 2. And that can be easily solved by for character in str, and I'm simply splitting this guy up into a string and operating on each of these. Let's see, I don't even need this anymore. I can just say C. Boom, this should work. Whoa. So not good with the timing. Although, what could have I possibly done to... Okay, let's actually take a quick look. Let's see, wait. How much was this off by? 70, and what is the best time? 40? Okay, let's try to see if we can speed this guy up by doing some small maintenance. Okay, also, I really think that we can get away with okay, let's see if this is better. Nope, not better. I think that we can get away with making an extra access call here by saying that char is equal to chars 1 string access call, and then at the end we can say next indx, so we don't have to char next next char, and let's say that this guy, since we're only using it once, let's see if this speeds it up a bit. Still no good. Yeah, what could I make faster here? Regardless, the algorithm works. Just want to make sure that you guys have a oh, it's the print statement. I completely forgot about the print. Yeah, so print statements take forever, so that was probably it. Let's see if the rest, yeah, that was definitely the print statement. We should be good now. Sweet. So yeah, beats 99%. I'm not sure you're gonna find a better solution. Yeah. Sweet. And we are doing this in constant time, by the way. We just have a couple of variables to keep track of different logistics of the algorithm, but the algorithm itself is sound and beats 99%. So yeah, feel free to use this, and see you later. Bye.